Okay, so welcome to our new lecture. In this lecture, we will be working with the rows and columns, and this is basically the outline. We will follow this outline throughout our lecture. First of all, we will import the pandas library as PD, and then we will create a dictionary. We have also already covered how to create a dictionary in our previous lecture and to import the dictionary in the pandas uh, data frame class and store in the df object. First of all, we will simply display this df object of the data frame class. It will print the data in the form of the uh, table. So as you can see that we have already printed the uh, uh, data frame that which we have built up from the dictionary. So basically all the keys in the dictionary have become the column labels, and the corresponding key list of keys has become the values of that particular column. As you can see that the Carla, James, Maria and David are the values under the name key, which became the name became the column label of the particular column, and then all the list of values have become the uh, uh, values of that particular column, and so is the case for the corresponding columns. So now if we only want to display the uh, a name column and the values under the name column, then we have to use the data frame object name, and then by using the angular brackets within the quotations we have to write only the uh, column label. So as you can see, we have got the data of the column labels only on the output, and here we can see that this is the data under the uh, name uh, column. Similarly, if we want to display only the uh, data under the name and qualification labels, and if we do not want the rest of the data, then we have to use a list of column labels here. Here you can see we have used extra two angular bracket here, which depicts that now it has become a list of the column labels. So if you want to select the multiple columns from the data frame, then you can use such a syntax here. As a result, you can see that we are able to slice the name and qualification column labels from the whole data frame, and we can see only the data of these two columns. Now I have again printed the original data frame, and you can see that using and printing only the data does not change the original data frame. Now adding a new column to the data frame. For this purpose, what we can do here is that we can use two options. First one is that by using the angular brackets, as we can see. So before using the angular bracket syntax, we have used the same data. So we have used the data from the dictionary and create a data frame and store it into the data frame object. And then first we have displayed the data frame so that we could see the original data. So in this case, the original data contains only the three columns, that is the name, height and qualification. And if we want to add a new column with the name address, so before adding the address, we have to create a list in which we will be specifying the addresses in the format of the strings. So this is nothing else but just a list containing the items as the string values, and we have stored it as the variable name address or identifier name address, which is actually a list, and then specifying the name of the new column which will be added in the data frame. So we have selected the name address with the capital A, and then we have assigned the list of values to that particular column. So we will be finally displaying that data frame. So as we can see that this is the data frame before adding the new column, and this is the resultant data frame after the addition of the new column, which is the address column. So now, just in case if you want to add this new column, that is the address, to a particular index, that is if we want to add this new column at index 1 instead of adding it at the end of the table, because name, the column heading name is currently lying at the index 0, and then height is at the index 1. So what if we want to add the new column at a particular index, that is index 1, that is after the name column and before the height column? So for this purpose, we can use the function that is the insert. So by using the function name insert and using the same strategy, that we have created a list of the addresses, and then instead of using the angular brackets, we have used the insert method. And this method actually in this method actually we have specified three arguments. The very first one is the index location, that we have specified that we want to add address at the index 1, and the name of the new column will be the address, and the values under this new column will be the list that we have created here. So now we have displayed the original data frame and then the resultant data frame, and let's see the result. So this is the original data frame. We can see that we have three columns so far, that is the name, height, and qualification. And after adding the new column, that is the address, at the column index number 1, you can see that this new column has been added after the name column and before the height column, because the index of the name column is index 0, and while adding this new column we specified that we want to add it at the index 1 when talking about the column. So the address has been added at the index 1, and the corresponding column headings have been shifted 1 indexes above. So far we have talked about adding a column. Now talking about deleting a column. So we have a variety of options. The very first option is deleting a single column using the drop method. So this is the data frame that we have created with the help of the dictionary. And first we will display the original data frame, and then we will be using the drop method. And because this is the method, so within the small bracket, first we will specify the column label, that is the address. And we also have to specify that because this is the column heading, so we have to use the axis is equal to 1. The digit 1 specifies that this address is actually the column label, not the row label. But if we have a row label with the name address, and then we will be we can use the axis 0. But since we know that we don't have the labels of the addresses, or sorry, labels of the rows so far, but instead the index number have been used. So just in case if we have a particular index labels for the rows as well, only then we can use that particular label here, and then we have to turn the axis from 1 to 0. But since we do not have the labels for the rows, instead we have the labels for the columns. So we have used the particular column label that which we want to delete from the data frame, and then we have used the access point which specifies that this is actually the column label, not the row label. So this is the original data frame before the deletion of a particular column. So after the deletion of the particular column, we can see that the resultant data frame does not have the address column, and it has been deleted from the original data frame. So now there is yet another way for deleting a particular column, that is the delete keyword. So using the same data, so first we will display the original data, and then using the delete keyword, we have specified the object name of the data frame, and then within the angular bracket, we have specified the column label that which we want to delete, and then we will be displaying the resultant data frame after the deletion of the address column. So now here we can see that this is the original data frame that contains the address column. After deleting the address with the help of the delete keyword, we can see that the resultant data frame does not have the address column anymore. Similarly, we can drop multiple columns, or we can delete multiple columns by using the drop method. So first we will displaying the original data so that we could see that what has deleted after the deletion of multiple columns. So now using the same drop method, within the small brackets, we have used a list, or we have used the list of the column labels instead of using a single column. So when we deleted the single columns, we did not use the angular brackets here because it is a single item, so there was no need of specifying the angular bracket. But now since we want to delete the multiple columns, that is why we have used the angular brackets here as well. And within the angular brackets, we can specify the name of the columns which we want to delete, and for separating the one column from the another, we have used a column here. And again, we have used the digit 1, which is essentially specifying that these labels are actually the column labels, not the row labels. So after the deletion of the age and address column labels, we will be displaying the resultant data frame as well. So after execution this particular code, we can see that this is basically the original data frame, and this is the resultant data frame in which there is no age and address column, because we have selectively deleted these multiple columns with the help of the drop method. We can also delete the range of columns with the help of the drop method. In order to do so, we can see again that we have used the drop method here, and within the small brackets we have used a kind of different syntax here. We have used the data frame object name here, and then we use the dot operator, and then the columns keyword, and then within the angular brackets we use the columns which we want to delete. And this is not like obviously this is the multiple columns, but this is like the range of the columns. So this is the starting range that we want to delete the columns from the index 1 up to the index number 3. The 4 means here that index number 4 will not be included. So index number 1, 2, and 3 will be deleted from the resultant data frame, which means that from column age to the column qualification, all the columns including the age and qualification will be deleted. So before deletion, we will be displaying the original data frame, and after deletion, we will be again displaying the resultant data frame, so that we could make sure that these two columns have been deleted. So by using the method that which we have specified here, we can see that the age, height, and qualification columns have been deleted, and the resultant data frame contains only two columns, that is the name and address column respectively. Okay, now there is another method as well to delete the range of columns. For this purpose, we have used the lock attribute of the data frame class. So by using the lock attribute, and then within the angular brackets we have first used the full columns, which means uh, all the rows values under the age column up to the qualification column should be deleted. So you have to note down this syntax actually here. So after using the dot lock and the range and specifying the range of columns, we again used the dot operator, the columns, and then we have updated the access is equal to 1. This will also result in the deletion of the columns from age to qualification in the resultant data frame, and we can see that there is no age, height, and qualification columns in the resultant data frame. So now talking about the rows. So in order to add a new row to the data frame, there are again there can be a lot of ways. So we will be only using the lock attribute in order to add a new row to the data frame. So first we will be displaying the original data frame, and then using the lock keyword within the angular bracket we have specified the uh, index where we want to add the new row. So obviously if we specify some indexes such as 1, it means that the index number 1 will be overwritten with this new information here. So because we don't want to overwrite any of the existing row, so that is why we have used the length of the data frame. So the length of the data frame will actually return the total number of rows which are already available in the current data frame. And let's suppose in this particular situation, first we can see that okay, mismatched scrolls. So we can see the error here. This error actually shows that the row which we want to add does not match with the total number of columns. So because this 38 was missing here, and since we can see that the original data frame contains 5 columns, that is 1 2 3 4 5, and the values which I had earlier specified are the 1 2 3 4. So that is why we have to add the value under the age column as well. So now we have the name, the age, the height, the qualification, and the address. So now if we execute this code will be executed exactly. So now you can see that a new row, that is the index number 4, has been added here, and with the respective data which we provided here. So this was how to add a new row here. Similarly, you can also update the information of any existing row as well by using this lock attribute of the uh, data frame class. Okay, now in order to delete a single row, so again uh, we have the drop method here for this purpose. So first we have again we will be first displaying the original data frame, and after displaying the original data frame we can simply use the dot operator and then the drop method, and then we have to only specify the index number which we want to delete from the original data frame. So after deleting the index number 1 row from the data frame, we will be again displaying the data frame. So let's see the result. So here we can see that this is the original data frame, and as we specified here that we want to delete the index number 1 from the original data frame. So after the deletion, we can see that there is no index number 1 with the corresponding data which was available in the original data frame, and the resultant data frame does not contain neither the index number 1 of the row and the corresponding data as well. So now there is a slight issue here that if we want to reset the index numbering, that is, since 1 is missing here, and if we want to create the next row as the index number 1 and then 2 respectively, so actually we want to reset the indexing numbering. So in order to do that, you have to use the another method, that is the reset underscore index, and then you must have to use the drop is equal to true, because if you do not use the drop is equal to true, the existing index numbering will become the new label in the data frame, and your data frame will become a little bit confusing. So the result that we are able to see is with the argument drop is equal to true. So you can see that the previous index numbers have been overwritten with the new data numbers, or in short, they have been resetted to the default values. So let's see if we do not want to drop or delete the older index row numbers. So just write drop is equal to false. In this way, you will be also able to see that after the deletion of the index number 1 and after resetting the index with the drop is equal to false, you can see that the previous index numbers have been incorporated as the new column. The column name will become the index, and the previous index numbers will become the data under the index. Since we do not want this type of column, so what we will do here is that we will set this drop is equal to true, so that the previous index numbers are not incorporated as the new column in the resultant data frame. So now we will execute this updated code, and then we will see that the previous indexes are completely overwritten. They are neither set as the new column nor available in the index numbers, and the fresh index numbers have been used here. So now, in order to delete the multiple rows using the drop, we simply have to use the list of rows. That is, again, we can see that angular brackets again dictating that this is not a single value, but instead a list of values have been used. So now we are specifying that I want to delete the only index number 1 and the index number 3. Please keep in mind that this is not the range. This is just specifying the two rows, that is row number 1, index number 1, and row index number 2. And now access is equal to 0 means that I actually want to delete the rows. If you by any mistake or by any means change this 0 to 1, then actually column index number 1 and the column index number 3 can also be deleted. There is a good chance, specifically in situations where you do not have used the labels for the columns and the default index values have been used at the labels. However, by using the access equal to zeros, it actually makes sure that these are not the column indexes, instead these are the row indexes. So after deleting the column indexes, we will again display the resultant data frame, and as we know that after deleting the index number 1 and 3, the resultant indexes will be disturbed. So in order to reset them to again from 0 in a descending order, we will again reset the index as we just saw in the previous code. So now let's run this particular code. So this is basically the original data frame, and here we can see that we have the row index number 1 available here, and the index number 3 row also available here. So after deleting the index number row index number 1 and 3 with this particular statement here, we can see that there is no row index number 1 and the row index number 3. But now, since the row indexes have been disturbed, we have reset the, or after resetting the index numbers, we can see that the indexes have been reset to the default values, and the desired delete data is also not available in the resultant data frame. So now, just in case if you want to delete the range of rows instead of using specific rows, what you have to do is that inside the drop method, just use the data frame name, and then there is dot operator, and then there is an attribute with the keyword index, and then you can, within the angular bracket, you can specify the indexes which you want to or you wish to delete from the resultant data frame. So then you will be printing the resultant data frame, and in order to reset the indexes, use this statement here as well. After carefully writing and examining the code, we'll again displayed the code. So first, since we have displayed the original data frame without deleting anything, so this is the original data frame. You can see that in the indexes number 1, 2, and 3 are also available in this. So again, because uh, whenever you talk about the range, then this 3 will not be including in that range, which means that from index 1 up to 2 will be deleted, and 3 is not included in that range. So you can see that index number 1 and 2 have been deleted from this resultant data frame, and again the indexes numbering is disturbed after the deletion. In order to reset it, we have used the statement here to reset the indexes number with the drop is equal to true, so we do not see the modified indexes, and then you can see the resultant data frame with the deleted rows as well. Okay, so this is it for today's lecture. See you next time for the next lecture.